Hello, my name is Ashley Plaza, and today I'll be going over the Caesar cipher and how it is used for encryption and decryption. So what is the Caesar cipher? Originally, it was an encryption-decryption method used by Julius Caesar to send encoded messages to his army. This way, if they were ever intercepted, they would not be able to be read without the decryption. It is a easy and simple cipher to implement and understand. All you have to do is take a letter and shift it a certain number of letters forward for encryption and the same number of letters backwards for decryption. Usually it'd be 3 letters for basic learning purposes, but it can be any number of letters. For this example, we were looking at this image. We have A through I at the top and X through F at the bottom. So if we were trying to encode the letter B, and we were using a shift of 3 for encryption, all we have to do is move 3 letters forward, 1, 2, 3, and we end up at E. And then the same thing for decryption is just backwards. We just move 3 letters back, 1, 2, 3, and we're back at B, which this image is showing by pointing every letter and its corresponding decryption letter. And that's the basic algorithm for this cipher. So you might ask, why do we use the Caesar cipher? One of the main reasons is its historical significance, as it is one of the oldest known forms of cryptography, making it one of the main ciphers people should know if they are trying to get into cryptography. And it also kind of gives a bit of insight into how people first began encrypting and protecting their information. Another main reason is because of its simplicity, as it is incredibly easy to understand and implement, making it a good choice for those who are trying to learn about encryption and cryptography. And it gives a good foundation for them to learn, as it teaches them about plain text, encryption key, and ciphertext. And it also requires few resources. So here we'll be going over a simple implementation of the Caesar cipher using Python. At the bottom here we have the main function, to the left we have the encryption function, to the right we have the decryption function, and that is all. So starting in the main function, first we take an input from the user by printing the statement, enter a message to encrypt. They will enter a message like hello world, hello, anything like that. And that will be saved to this variable here, text. And then we also establish a variable shift and we set it to 3. This will be by how many letters we are shifting in the alphabet for the cipher. It could be any number, but for this example we're going to be using 3. So then we go into the encryption itself. So we call the Caesar encrypt function and we pass the parameters, the text that we were given, and the number for the shift. So then going to the encryption function. First, we establish a variable encryption and set it to an empty string. This is where we will be saving our ciphertext once everything has been processed. So then we go into a loop. We're saying for I in the range of the length of the text. So we're going to be going through every single letter of the text given. And we establish a variable here, char, equal to the first element of the string text. This way we can go through every single letter in the string and keep it as this variable char. So then we are saying if char is not alphabetical, then just keep it the same and add it to the encryption string. This is to keep this specific program very simple so that it's easy to understand. So any special characters or letters or anything that is not alphabetical will just be kept the same and saved to the ciphertext, just for simplicity. We could always change this, but then it would take a little bit more time and more fine-tuning. But since this is just an example, we're gonna just keep that the same. So then if it is not non-alphabetical, then we go into the elif statement and we're asking if char is an uppercase letter. So for example, we say the first letter is an uppercase A. So then we go into this statement right here. So the first thing is we take the character, uppercase A, and we transform it into the Unicode number using this OR function right here. So for this case, uppercase A would be transformed into the number 65. So onto that number, we are adding the shift that we are using for this cipher, which is 3. So 65, 66, 67, 68, that would give us 68. And then we subtract the 65 again to kind of set it back. So it pretty much sets all the letters in the uppercase alphabet to 0 through 26, I think, yes. So A would be 0, B would be 1, C would be 2. So this just kind of keeps everything shifting properly. And then we take whatever numbers gathered here after we shift the 3 letters. And then we use modulus 26 to make sure everything wraps around. So this makes sure that if we're shifting 3 letters forward, we're still staying within the range of uppercase letters. For example, say we were shifting Z, you don't want it to shift into a special character or a number. You want to keep it within the range of uppercase letters. So this just makes sure it loops around to the 26 letters of the alphabet in the uppercase. And then we add 65 again just to go from 0 to 26 back to the numbers for the Unicode uppercase letters. So once all the calculations are done to make sure we shift 3 letters forward in Unicode to get the next the encrypted letter, we change the number back into a character using the char function, and then we save that to our encryption string. So then say our alphabetical letter is not uppercase, then it goes to this else statement where we handle lowercase letters, and we do the same process, but instead of 65, because 65 is for the uppercase A, we use 97 because this is for lowercase a. So that just makes sure that everything stays within the range of lowercase letters. And it's the same process as before, just for lowercase letters. And then once that is all done, we save it to this encryption string, and the process repeats again and again for every single letter that is in the string that we were given text. And once that's all done, we return the encryption statement string, which is the ciphertext. So that is returned and saved then here to the variable Cipher, which is our ciphertext. So then we go to the next line, and here we are printing the input text just for the verification of the user, so they can see that the input text that they gave was properly saved. And then next statement, we have another print where we print Caesar encryption, and then we print the ciphertext we've gotten before. And then following that, we have another print statement. We have Caesar decryption, and this is instead of calling the function and saving it. Oh, sorry. Instead of calling the function and saving it to a variable, we are just directly calling the function and passing the parameters the ciphertext and the shift. So then it goes into this decryption function, which is a mirror of the encryption function, but instead of shifting forward, we're actually shifting backwards, as you can see with this subtraction sign here. And it's the same thing, uppercase letters is 65, lowercase letters is 97, we have the 26 for the 26 letters of the alphabet, and we keep everything the same. It loops through the entire text and decrypts all the letters, and then at the end we have the return statement to return the plain text we had got at the end of that, and then it's printed here in the last print statement. So here we have 3 outputs to show how the program works. The first takes in the input message hello world, it prints the encryption, and it prints the decryption. The other encrypts the message coding is fun all together, and it shows the encryption and decryption, and the last shows the input text I am thinking of moving to Texas, and then it prints the encryption and then the decryption. So thank you for listening to my presentation today, and I hope that you were able to learn a bit more about Caesar Cipher and see how it is implemented in Python.